Hello, everybody. My name is Alberto Comazzi, and today I would like to talk to you about how to find experts using the NASA Astrophysics Data System. So let's start by defining what we mean by an expert in any given field. There's no single answer to the question of finding an expert on a field or research topic. While it's easy to identify some well-known scientists such as prize winners in any subdisciplines, it's not necessarily straightforward to do so for more specialized or obscure research areas. Additionally, one may need to find an expert in a particular subject area who also has specialized knowledge in certain methodologies or experience with certain data sets. So for the purpose of this presentation, we will consider the problem of finding an expert in any particular subject area, which could be as broad or narrow as desired. Here is a list of potential answers to the question, who is an expert in any given field? It could be somebody who's publishing recent papers in that field, someone who's written highly cited papers in that field, somebody who's writing highly popular papers in that field, or someone who's writing highly relevant papers in that field. Depending on how we pose the question, we will introduce certain biases and selections in finding these people. And for each one of these questions, there are a number of potential pitfalls. This is simply meant to illustrate that there isn't always a one-size-fits-all approach to answering the original question, and each approach may have issues that will bring you to different conclusions. So let's see how the ADS can help in finding some of the relevant experts. How can we use a system like the ADS to find experts? Well, we can start by observing that experts can be identified as prolific authors of topical papers on our subject of interest. And here's a recipe for finding these people. We start by searching by topic or by selecting a set of relevant papers. We look then at the list of authors who published most of them. We use selection criteria based on publication dates, citations, and readership to limit the selection to the most recent, most cited, or most read papers. Or we find the most relevant papers and then use the ranking of relevancy to select the top N papers that are most relevant to this topic. Finally, we review the list of associated authors to find key experts in the field. As an example, let's consider the case where we want to find experts on the topic of solar wind. So let's go to the ADS interface, and we can easily create an ADS query for this phrase, which will find results. If I submit the query that contains solar wind as a phrase to the ADS, you can see that I'm finding over 64,000 results. What we're looking at here is an exhaustive list of all papers which contain the phrase solar wind, and the long list of associated authors listed here on the left are people who wrote these papers. If we look at top of the list, we find that the most prolific person is Christopher Russell, who appears at the top with about 1,500 papers on this list. But we also notice that there is a long distribution in the histogram of papers over time. This shows that a lot of these papers have been published over 20 years ago. So some of the authors of these papers may have retired or may no longer be working in this field. Something to keep in mind as if we're looking for active researchers. So what we're going to do next is narrow this list by selecting criteria mentioned before. Let's start by looking at who are the most prolific authors among the population of recent papers. So to do this, I'm going to just select in this histogram the last 5 or 6 years and apply this selection to the original list of papers. As you can see, we find a much different list, or a different list of authors in this under the author filter. In this case, we find that Stuart Bale is a prolific author, and also Jasper Halikas is one of the most prolific authors, while Christopher Russell was still present, is now in the third position. So let's go back a step and analyze another way to do this. As mentioned, we could make a selection based on the citations of these papers. So if I go to the citation tab and look at the, let's say, 500 most cited papers in the set and apply this filter, I will find yet a different list of experts in this author list. Finally, we can look at results that we obtain when we rank and trim the list based on readership. So we can ask ourselves, what are the papers most read today? So the most popular papers on this topics, and who are the people who have been writing them? And once again, we get some of the same names, Stuart Bale, but also Justin Casper, and so on. Each one of these selection criteria will introduce different biases. So if we look at citations, we will notice that the highly cited papers tend to be older rather than newer because of the time bias introduced by this. Similarly, most read papers tend to be recent papers, and therefore these are authors that have been publishing most recently. There's one more way to sort this list in a way that is worth mentioning, and that is by relevancy score. We can simply ask ourselves, what are the most relevant papers in the regarding solar wind? So I'm going to select score as the sort method. And we now still have a list of 64,000 records, as you can see, but they're now ranked by relevancy to the original query. So for instance, solar wind appears in a lot of the titles of these papers. One thing that we can do now to narrow this list so that we can see only the most relevant ones and only the authors who have written the most relevant ones is to select all the papers on this page. What I've done is I've selected the option to see 500 papers per page. So this gets me as many papers on this page as the application allows. Then I'm going to select all of them, and then I'm going to click on this button that says limit the list results to the 500 papers that I've just selected. If I do that, the system will create a temporary collection of 500 papers, and then it will show me the relevant authors associated with these papers. And as you can see, the list is different than the ones we've seen before, although some of the peoples are still common. So this is just to show that there are at least 4 different ways to ask the question about what are the most relevant papers or most interesting papers on this topic, and combining multiple of them may be the best way to find the answer to our expert question. Let's consider the case where you're interested in finding expert reviewers on a fairly narrow topic, which is more challenging. For instance, somebody who would have in-depth knowledge of an instrument, project, or particular methodology. The problem might be that if you start with a narrow list of papers on the topic, it may be difficult to identify someone who's suitable, especially if you're trying to avoid conflicts of interest. This is where the ADS's most advanced exploratory features can be helpful. Whenever you start with a short list or even a single paper, you can easily explore associated works by leveraging on the papers connected to them through citations or readership. Let's look at some of the possibilities. Who makes a good referee for a particular topic or technique? People who write review papers on the topic, people who are oftenly cited by those who write papers on the topic, people write papers similar to papers on the topic, or people write trending papers on the topic. For each one of these categories, ADS provides a search operator that allows you to find papers in these different categories and then the authors that have written them. And this is explained by this brief diagram, which is also available on our help pages. By using, this is a brief illustration on how these operators work. Given one or more papers on a topic, the reviews operator returns a ranked list of papers that most frequently cite the original paper. The useful operator returns the list of papers that are most frequently cited by the original papers. The trending operator returns the list of papers that are most frequently read by the readers of these papers, and the similar operator returns the list of papers that are most semantically similar to the original papers. Essentially, all of these operators work in a similar way. They take some of the papers and explore the citation, usage, and topic networks to produce additional records that might be useful for our goals. So this leads us to the following recipe to find expert by exploring papers related to a topic, however specific that topic might be. We start from a list, then explore the connections between that list and the rest of the literature. Then we trim the resulting ranked list to view the key authors who wrote the most relevant papers. And as an example, consider the keyword solar winds paired with the keyword SWEP. Let's do this search, solar winds, SWEP. SWEP is an acronym used for the solar wind electrons, alphas, and protons investigation, which makes use of instruments aboard the NASA's Parker Solar Probe. If we run this query, we can see that we find a list of 91 papers, most of which are authored by Justin Casper, who is the PI of the SWEP project. If we analyze and explore the author network, we can see that there are numbers of collaborators represented in this network. And they're clustered by how frequently these authors have written papers together. However, if we view the overlay, we can see that authors in one cluster also have co-authored paper with authors in other clusters. So it may be hard to find an expert among this short list of authors who has not interacted or published with other authors. So this makes it challenging, especially if you're looking for a referee who has not previously collaborated with someone in this set of authors. So let's look at what papers the system finds using the reviews operator, which is also available under the Explorer menu. If I select reviews, the system will rewrite the query as reviews of solar winds and SWEP, and it will generate a larger list of 291 papers. We see that the list of authors associated with the papers have changed. Now Stuart Bale is the most prolific of this set. And we also have Michael Stevens listed as one of the top authors. Let's take another look at what happens when we select the useful operators. These are papers that represent the cited literature, all the papers that have been cited by the original set of solar wind SWEP papers. And again, we find some of the names what we find earlier, but I want to point out that it's yet a different list. Finally, let's go back and look at what happens with the trending operator that uses the co-readership network. So we look at the co-reads, and we get a yet slightly different list of the authors associated with them. So let's see a final example by using the similar operator. So if I go under Explore and select Similar for the original query, this will run a very expensive operation, because what happens under the hood is that we run the original query for first order query. We generate a list of first order results and then sample the textual content of the results, extracting key terms from them. And then we rerun a search based on the entire database for all such terms, returning a ranked list of the most relevant ones based on semantic similarity. As you can see, this is an expensive query, which generates a huge number of records, over 7 million of them. Although the most relevant papers will be found at the top of the list, since it's a ranked list and it's ranked by score. However, if we look at the authors list, it's kind of useless, because these are authors, all the authors that have written 7 million papers. So once again, in order to obtain a reasonable list usable for our purpose, we need to subselect the top ranked papers in this list and then limit the results to this list of papers. Once again, we find a list of the usual suspects, as you can see here, which confirms that these criteria are fundamentally valid and useful in selecting content and associated experts. So going back to our plan for finding referees, one more thing that we need to worry about, obviously, is avoiding conflicts of interest. In order to make sure that peer review is fair, one has to take care of these potential conflicts of interest. So for instance, we want to avoid people from the same institutions. However, people move and collaborations span across institutions. It's better to actually avoid people that work or collaborate together. A solution to this problem is to visualize the author network, as we've done before, discover collaborations, and then avoid selecting people within the same group. So if we go back to our example of 500 papers on this topic, we can pull up the author network once again. And first thing to notice is the network by default is built on the top 400 papers in the list. So in order to make sure that we capture everybody who's represented, I'm going to update it by asking that 500 papers be considered. As usual, we can see the different clusters. Here's the group at the CFA and that worked with Justin Casper. If we enable the link overlay, we see still a lot of connections across groups of authors. But if we're specifically looking for connections of one person, we can go and highlight that person in the graph and observe all the co-authors and where they appear along this donut. In this case, if I'm looking for somebody to, say, review a proposal submitted by Justin Casper, I would want to find a cluster of people that have not co-authored with him. So in this case, I'm noticing that the group at the bottom, the green group here, does not seem to have any connections with him. So one good set of candidates for reviewing his work would be people that appear in this cluster. So what I'm going to do is select the cluster, add to the filter, and then request that ADS displays the papers associated with this cluster. So what we've done is we have filtered the original list of 500 results down to 53, and we've found a list of authors that have no connection with Justin Casper, but who are experts according to the methodology that we use to detect them. So any of these papers, any of these people might be good reviewers in this case. So in summary, I've demonstrated some tools that ADS provides to allow users to discover relevant content and associated researchers. Depending on the task, a multi-step selection process will be required to decide which methodology to be used to select the papers in question and then the authors that have written those papers. The authorship networks are useful for identifying groups of people working together and the interactions between people. The final selection process is ultimately, for selecting referees, is ultimately best left to the editors or experts in the fields who will analyze all the criteria used to select the papers and then methodologies for removing conflicts of interest in this process. Thank you for listening.